Hey, Mike, are you still there?
I'm sorry, I appeared to hit mute. Um,
All right.
yep, yeah. So Frank is a senior server, a senior SQL Server DBA with 8 years experience working with large scale um, environments. Interested to hear his perspective on how he can work with data corruption in a large database environment. He's worked previously that as a mainframe programmer, COBOL rules. Um, he, he's developed a love for all things internal. That's great. Um, when not administering databases or just geeking out on internals, he volunteers at the Art Institute of Chicago, and he reads voraciously. I like to read too. I think I'm going to have to start reading this author called Voracious. That sounds exciting.
I'll send you a link.
All right, thank you, Frank. And with that, Frank, I am going to pass you control. Um,
Okay.
and
All right. Can you see my slides?
not yet. I don't see it yet.
All right. Just went green for audience view.
I'm getting a notice. Here it is. I see it now.
Okay. So, as Mike said, my name is Frank Gill. I am a SQL Server DBA. I've been doing it for about 8 years. So there is kind of what Mike talked about. I did start out as a COBOL programmer, and that got me really interested in internals because when you're working with COBOL, you're very close to the machine code. Basically, you can work with assembly language at that point. And when I moved into the DBA area, I was very fortunate to have a mentor who was very interested in the internals of SQL Server, and that got the ball rolling. So my contact information is here. This will be up at the end as well. If you have questions about anything that I talk about, any questions about internals in general, you can shoot me an email, hit me up on Twitter. I'd be happy to talk to you about it. I really like to talk about this stuff, and my wife doesn't. So any questions are welcome. Just to go over what we'll cover in this presentation, I'll start kind of at a very basic level as to what corruption is, what happens when a database becomes corrupt, ways to identify corruption, both kind of at an ad hoc level and then at a more general level at a database level. Talk about I/O error codes that'll get flagged when corruption occurs or when corruption may be about to occur. And then I'm going to talk about DBCC CHECKDB, which is a way to check an entire database for corruption, check the integrity of a database. DBCC page, which is a command that will allow you to dump the contents of a page to a table or to the results in Management Studio. And then finally, I'm going to run through a process that I wrote to scan a database for corruption, identify what pages are affected by that corruption, and then show the data that is affected on those pages. And when we get there, I'll explain why I ended up writing this process. So starting with what corruption is. SQL Server stores all of its data on units that are called 8K pages, or they're called data pages, and they are 8 kilobytes in size. Those pages reside in data files on disk. But anytime SQL Server does anything to data, if SQL Server reads data, if it inserts data, deletes data, updates data, the pages are pulled into memory from disk. And the reason for that is it's a lot faster to access data in memory than it is to disk. If you had to hit disk to make these changes, you'd be dealing with the path out to the I/O subsystem, modifying the data, and then having some sort of a notification come back. By pulling that data into memory, speeds that process up. It's basically straight across the copper to memory. So I said pages reside in data files on disk, and anytime that you modify or read data, it is going to pull that page into memory. So I've got my red border around my page. That page is now resident in memory. So if I do an update to that page, my black data are now modified. So I have changed that data. That page can continue to live in memory because, once again, it's a lot quicker and less resource intensive for SQL Server to maintain that page in memory than it is to try to push that back out immediately. So it will stay in memory for some period of time, and then there are processes that run, checkpoint processes and cleanup processes that run, that will flush that page back to disk. So eventually that page with the modified data gets written back to disk. Now corruption happens when in that path from memory back to the storage, to your disk, through that I/O subsystem, or while that page is at rest on disk, something changes. Something causes data on that page to change. If that occurs, that is corruption. So at its root, that is the definition of corruption. That in that path from memory to disk, or while the page is on disk, something on that page changed. So there are a couple of different ways to identify corruption.
Frank, I seem to have lost your audio. Are you there? Okay, everyone. Frank's connection got dropped. He's trying to reconnect right now. I'll pause the recording. Yes, you're back.
Okay, yeah, it said that my audio connection had dropped, so it is now reconnected. So I'll keep an eye on it. Can you see the chats that I'm typing into you?
Yes.
Okay, I will. If it happens again, I'll let you know.
Okay, thank you.
Where did you lose me? Did you lose me at page verify?
Yes, just when you switched to that page, the audio disappeared.
Okay, so basically I was starting to talk about ways to identify corruption, and the first one I'll talk about is page verify. So page verify is a setting at the database level, and as you see, it's got three possible settings. I won't talk about none because it's fairly self-explanatory. If you set page verify to none, SQL Server will do no checking of pages for potential corruption. The second one is torn page detection. I believe torn page was introduced in SQL Server 2000, and then the last is CHECKSUME, and CHECKSUME was introduced in SQL Server 2005. So what torn page detection does is when SQL Server is in the process of writing a page out to disk, so the page is in memory, it's been modified, it's been read, before SQL Server writes that page to disk, it scans the page, and as it's writing the page, it flips a bit after every 512 byte section of the page. So your page is 8,192 bytes. It's going to write 16 bits to the page or flip those bits as it's writing. So my example here shows 8 rows. It would actually be 16 rows of data, just a lot cleaner with 8. But once it writes out, all of those bit values should be the same. So in the example you're looking at here, I've got 4 zeros and 4 ones. So something went wrong while this page was being written to disk. And if those values are different, SQL Server is going to flag this as being corrupt. Now, this is great because it will flag any sort of a write error, but in the case that data on this page changes either in that path from memory to disk or resident on disk, torn page detection will not catch that. So this provides a level of protection, but it isn't the best level of protection. The best level of protection is checksum. So what happens with checksum is prior to that write to disk, SQL Server scans all of the data on this page and uses it to calculate a checksum value. So the checksum will be equivalent to all of the data on that page. When SQL Server reads that page back into memory, so it's in memory, it's been modified, the checksum value is calculated, and it's written back to disk. The next time that page is read into memory, SQL Server will recalculate that checksum value, and it'll compare it to the checksum value that is actually stored on the page. If those values are different, you've got corruption. And as I said, this will check the entire page. So if anything on that page changes, if one of those torn page bits gets flipped or doesn't get flipped properly, the checksum will catch that. If any of the data on the page changes, the checksum will catch that. So it's kind of best practice to make sure that checksum is your page verify setting for all of the databases on your system. I've got a link in my resources section that talks about the difference between torn page and checksum. When checksum was initially introduced with 2005, there were some concerns about the processing hit you were going to take because it's actually doing this checksum calculation for every page. If you have a very large database, you've got a lot of pages. So the article I've got kind of talks about it from that perspective, but in today's world with processing power that's available, kind of the hit that you're going to take is minimal compared to the level of protection that you get with checksum. So Mike, at this point, do we have any questions?
Yes. Should checksum be enabled on TempDB?
Yes. Yeah, it should be enabled for all databases because you want to be able to determine if there's an issue. There was an issue with a client that I worked with last night who had corruption in TempDB, and we have checksum set there, so it helped us catch that.
Okay, thank you. That's it.
All right. So those page verify and checksum will cause error codes to be raised in the transaction log. And you can actually set up alerts within SQL Server Agent to alert out when these errors are seen. There are 3 I/O error codes that you will see, and they are listed here. 823 is an I/O, it's an operating system error. So SQL Server has determined it needs to get a page from disk, and it makes a request to Windows to pull that page back from disk. For some reason, when you see an 823, for some reason Windows has not been able to get that page. Either the address that the page is sitting on in disk is not available, there's a corrupt sector, there's something physically wrong with the disk that is preventing Windows from pulling that page back. An 824 is a logical consistency error, so that is a page verify, some sort of page verify error, either torn page or checksum. And so if you see one of those, an 824 indicates that it, either the torn page bits were not set to the same value or your checksum values are different. So those are both hard errors. They will kill your connection. If you run a query that runs into one of those in Management Studio, it will kill your connection. The database, the connection from the application will be killed, and you will get an error in the, is it coming through any clearer now? Okay. I'll try not to move around so much. So you'll get an error in the error log that will tell you that these errors have occurred, and they'll be hard errors. And like I said, within SQL Server agent, you can set up an alert for those errors and have it alert out via email or page. 825 is a different animal. So 825 is going to be a warning. And so whenever SQL Server hits an 823 or an 824, it will retry 4 times. So it gets an operating system error, Windows will try a second, third, fourth time. If things succeed on any of those subsequent tries, SQL Server will process as normal. It will just keep going like nothing happened, but it will spit an 825 out into the error log. Same thing for an 824. It gets a checksum error or a torn page detection error. It will continue if it succeeds on the subsequent tries, and it'll give you this warning. So this is one that you really want to set up an alert within SQL Server Agent, because this is kind of the canary in the coal mine. If you start to see 825s with frequency, you have an idea that corruption is about to occur. And this is the reason that you want to have a good relationship with your SAN administrator, and you want your SAN administrator to kind of understand how SQL Server works in terms of corruption, so that you can go to your SAN administrator and say, I'm starting to see these 825s. What can we do to look at the storage and see potentially what's going on? Because there's a very good chance if you start to see 825s, you're going to see 823s and 824s start to come through. So that's I/O error codes in a nutshell. From there, I'm going to talk about DBCC CheckDB. So any questions about I/O error codes, Mike?
Not directly about that, but there is a follow-up question to CHECKSUME, and it's essentially what kind of overhead is it to enable that?
So you flip it on. It's a configuration setting. So you make a change with spconfigure to change it. Actually, no, sorry, it's an alter database. It's an alter database command. And there is no overhead at that point in time. When you flip CHECKSUME on, it doesn't actually do anything. It's basically a metadata change. It's only when the page is read into memory and written back out that CHECKSUME will be calculated. So a good way to do this is to flip CHECKSUME on. If CHECKSUME is not enabled for the database, turn it on and then run a rebuild of all of your indexes. And so that'll pull all of the data into memory and then write it back out. So when you flip the setting, there's no overhead. The overhead's only going to hit when the page is written back out. And as I said, it's a fairly minimal operation. It's just you're going to be doing it for every page. So does that answer the question?
Yes. Let's see. There's a couple others coming in here now. Can you set CHECKSUME as a default when you're creating a database?
Yes. If you turn it on in your model database, it'll get picked up when you create a new database.
Okay. Sorry. Let's see. There's quite a bit on it. Where does it actually get? Where do you actually set the CHECKSUME? Where do you tell it that you want to do the CHECKSUME?
So you'd run. It's an alter database statement. So alter database set page verify CHECKSUME, and then the CHECKSUME actually gets written to the page. And when I start dumping pages out, I'll show you where it shows up.
Okay, let's see. Does a virtual environment have any effect on corruption in SQL?
No, I mean basically you're dealing, even if you're running virtually, it's using disk and memory the same way it would in a physical server. So that path to the I/O, all of that stuff is the same.
Okay. One last question, similar to how do you turn on CHECKSUME? How do you set up the alerts for the 823, 24, and 25 errors?
So I can show you when I get into Management Studio. I can just show you very quickly. Let me get through to my demos, and then I'll get there.
All right, back to you.
So, all right, cool. Well, thank you for the questions. Those are good. So I'm going to talk about DBCC CheckDB now. So page verify and IO errors are all occurring at the page level. So it's going to be, as you're processing, it's going to identify individual pages. So it's possible that you could have a page sitting on disk that has been corrupted, but until that page is actually accessed by the instance, by the database, you are not going to see that corruption. DBCC CheckDB is a command that will run an integrity check on the entire database. And this runs a number of steps. These are four very simplified bullet points of what CheckDB does. I've got a link in my resources section to a blog post by Paul Randall, who wrote DBCC CheckDB, and he goes through in very fine detail about each of the steps that CheckDB runs. So if you're interested in internals, it's a really good place to go to get a handle on exactly what CheckDB is doing. And when you run through these demos, and I'm actually going to corrupt a database to diagnose, you can run through this and look at Paul's list, and you can get a handle on where the corruption is actually showing up. But at a very high level, what CheckDB does, the first step that it does is it creates a transactionally consistent snapshot of the database. And what that means is it creates effectively an empty file. And as changes are made, so CheckDB starts and it creates the snapshot, and there's a timestamp associated with the snapshot. Anytime a data page is changed after that timestamp, the image of the page prior to the change will be written to the snapshot file. So when SQL Server is running its analysis of the data, if the page has changed after that timestamp, it'll hit the snapshot file. If it hasn't, it will hit the actual data file. And this way, processing can continue, and DBCC CheckDB has a transactionally consistent view of the data. Once that snapshot is created, it begins by doing a check of critical system tables for consistency. So basically, the tables that SQL Server uses to tell it where other stuff is in the database is checked first. And if there's corruption there, DBCC CheckDB will stop. Because if it's got corruption in these critical system tables, it's not going to be able to find the other things it wants to check. From the critical system tables, it goes and it does allocation checks. So SQL Server uses a series of pages that are specified as allocation maps, and they tell SQL Server what pages are allocated, what kind of pages those are, if they are data pages or index pages, and there are allocation maps that have information about what indexes are allocated in a database. So it does those allocation checks. Once again, if the check fails there, it will stop because it won't be able to find out where the pages associated with other system and user tables are. And then finally, it runs through logical checks of system and user tables. So it effectively does your page verify check on all of the pages in the database. And that is dependent on your page verify setting. So if you have it set to torn page, it's going to do a torn page check on every page. If it's set to checksum, you're going to do a checksum check. And that is the process that it runs through. As I said, if you go and look at the link to Paul Randall's posts, you'll see much more detail there. So from there, that's DBCC CheckDB at a very high level. And then I'm going to talk about DBCC page. So DBCC page allows you to dump the contents of an 8K page. You can return this as text, and it will give you output in your results pane that is formatted text. For the examples that I'm going to use, I am going to dump this to tabular format. So it will show up in your results in a grid format like it would if you were running a select with grid results turned on. And I believe I will show you examples of these two things now. So just to show you the syntax for DBCC CheckDB is DBCC CheckDB database name, and then there are a series of params that you can pass in here. I'll talk about what a repair allow data loss is later in the presentation. I believe this up. So DBCC page, the way that it works is it's DBCC page. You give it a database name, a file ID. So if you got more than one data file in your database, this will be the idea of that file. You give it a page number, and then this last parameter is a format. 3 will give you the most information. It's 1, 2, and 3. I'm going to work with 3 here. And you will, you can look at, there's a link in my resources section that talks about DBCC page, and you can see what 1 and 2 do. The one thing I want to point out is that if you run this straight like this, you need to turn a trace flag on to get the results to spit out. If you run this by itself without flipping that trace flag on, it will tell you that DBCC execution completed. It doesn't give you any information. If I run this with the trace flag on, you will see results spit out. And just quickly looking at this, this is the contents of the data page that I've specified, and you have information about where that page lives in the SQL Server buffer pool, so where that's living in memory. And then there's some header information here. And one of the things you will see in here is this torn bits column. So this is where the page, the checksum would show up. Let me run it for a different page. Let's try 329 really fast. And that's an index page, so that's not what I'm looking for. There we go. Yeah, so once again, torn fits is set to 0. So let me, when I get into the demo, I will do that again, and we can actually see a page, our checksum value. The other thing I want to show you is just if you run this with table results, you do not need the trace flag, and you will see that this is generating tabular results. This is an index page, so it's showing 2 result sets. Let me run this quickly and actually get, all right. I'll go through what this is in a second. I just wanted to be able to dump out a page. So if we dump page 328, which is actually a data page, this is the tabular result set. And down in here, I have my torn bits, which is set to 0. So not entirely sure why I'm not getting the checksum. It's just that I haven't written the page out to disk. But let me get into the demo in a moment, and we can take a look at that. So there, jump back.
Hey, a quick question here while we're transitioning.
Sure. Yep.
Is running CheckDB on a backup of a database the same thing as running it from the live database?
It isn't, because there could have been data that changed in the live database, but that is a solution if you want to do a restore to a different system and run CheckDB there. That is something that you can do. Basically, CheckDB is something you should run with some frequency, and if it proves to be, resource intensive enough that you can't run it against your live database, backing it up and restoring it somewhere else and running the CheckDB there is the next best solution. So you're potentially not going to catch corruption that's occurred since that backup happened, but you will be able to see if there's corruption in that data that's been backed up.
And one follow-up question to that, if you are using availability groups and have multiple replicas, can you run CheckDB on a read-only replica?
That's a really good question, and I don't know the answer. I believe that you can
Oh, that
on
was
a read-only replica, but I would have to. That's something I'd have to test out. I will put that on my list of stuff to add to this, and I will try to get an answer out there in the slides and scripts that I provide. All right. Any other questions?
Not for now. We're all set.
Okay. So I'm going to go through the demo to identify corrupt data. And the reason that I wrote this process is that we had a client. I work for a managed services company, and we do project work, and we were migrating a client from an old production environment to a new production environment. And we set up the databases, we moved them over to the new production environment, and we set up our standard maintenance. And one of our maintenance jobs runs DBCC CheckDB on a nightly basis. And so we got the databases over to the new environment. The CheckDB job ran on that first instance, and it flagged data as being corrupt. And so we went to the client and we said, hey, we've seen corruption in this database. How do you want us to proceed? And the first thing they asked us to do was to run CheckDB on the source system, which was their live prod system, and we didn't see it over there. So they were still concerned about it showing up in the new system. So they asked us to tell them what data was actually affected by the corruption. And there is no, I mean, you can look at DBCC page or DBCC CheckDB results and kind of scan each page to see what data is affected, but that's not very it's not very efficient. So I put together this process to run CheckDB, identify what pages were affected by corruption, use DBCC page to dump those pages out, and then take that result set and parse out the actual row values that were affected. So I'll jump back over to my demo. And what I'm going to do is I'm actually going to use a hex editor to corrupt a data page. And so what I'm doing here is running a query against a dynamic management function that is called DMDB database page allocations. And you pass this a database ID, an object ID, I believe this is a file ID, and then this detailed parm will give me all the information I'm looking for. So I'm running this select into a temp table, and I'm pulling back information. The information that I'm most interested in is the page ID. So this is the ID of the data pages on my system, and want to select out the minimum page ID where my page type is equal to 1. A page type of 1 is a data page. Comment this out because that'll show me my index pages. But I want to get the minimum value for a page ID for a data page. I then want to get an offset. So each page is 8,192 bytes, and they are written into your data file sequentially. So your page number times 8,192 will give you the offset of that page in your data file. And I'm going to use a hex editor and that offset value to navigate to the page in the file and then corrupt it. So if I run this, all right, let me drop my temp table. All right, try that again. So my minimum page value for a data page is 328. That value times 8,192 is this value. So if I copy that out, to modify a data file like I'm doing, and I advise you not to do this on any system you care about, Do it on an instance running on a VM on your laptop, as I'm doing. Do not do this in production. If you do this in production, you are looking at a resume updating event. But I want to take my database offline so I can make this change. And so my database is now offline. So I can open up my hex editor, and I've got a link to the hex editor here in this script, which will be available, and it's also in my resource section on the slides. XVI32 is a freeware hex editor, so you can download this for free. So I'm going to open this up, and I can open a file, and in this case I'm going to reopen the MDF for my database. We'll open this up, and you can see that I'm now looking at the actual contents of my file. Over here on the right, you will see the ASCII representation of the hex characters over here. And I can scroll through, and it's not terribly exciting because this is the beginning of my file, and this is all machine code. But if I come up here to search, actually address and go to, I can paste that offset value that I got by running my script in, click OK, and it will navigate to my data page. So this is the first data page sequentially, and you can see my data here. This table contains an ID value, a phone number, a first name, and a last name. So the ID number is over here somewhere. It is a 01, so it's not showing up as an ASCII value. But here's my phone number, here's my first name, my last name, and then you can see it continues down and through. So to corrupt this, I can just change one of these values. So I've got Liam Johnson. I can change this to Miam Johnson, and that is now changed in my file. I can save this, and then I can come back over to SQL Server, and I can bring this database back online. That completes successfully, because when you set the database online, there's no sort of integrity check that happens. But if I attempt to run a select from that table, it gives me an angry red message, and it tells me that SQL Server has detected a logical consistency-based I/O error. So it's got an incorrect checksum. Here's what it expected. I don't know why that jumped, but this is the value it expected, and then this is what actually occurred. That's what it recalculated on the read into memory. It tells you what page is corrupt and what the offset is in the file. So that is what the corruption looks like when you're trying to run that select. So the next thing I want to do is I want to execute CHECKDB against that the database with table results, and then there's another parm out here called no info messages. So if I was to run this without that parm on, it would show me the results of everything that succeeded. And that's great. I want things to succeed, but in this case, I don't care about those info messages. I only want to see the error messages, so I'm going to suppress those info messages. And I'm going to insert that data into a table that I've created into my database. So I'm running dynamic SQL here, running through, and this is actually set up to hit all of the databases on a system, because in the case of the client we were working with, we just wanted to make sure that there were no other databases that had corruption. I've got it set up just to hit the corrupt demo DB. So I'm going to run this, and this is what it generated. So because I've got no info messages on, it's only showing me my errors, and you can see the errors that are here. And this, these will be similar to what we saw in red when I was running the ad hoc select. And in this case, you see this IS off buff IO error. This is the equivalent of a checksum error in the message text. And you'll see that it gives me the page that's affected, In this case, it's page 328, and then 330 is an index page. Tells you the object that's affected. And then this repair level. So I've got two different values here. I've got repair allow data loss and repair rebuild. I believe I've got a slide later on that talks about these. But repair allow data loss means that you can run DBCC CheckDB with that parm, and it will actually do whatever it can to fix the data. And that can include losing data. So you want to use this with caution. Repair rebuild, if that's the only repair level that you see in this result set, it's possible that you can rebuild a non-clustered index to fix the corruption. Because if your clustered index is still valid, your non-clustered indexes are referencing that clustered index, and rebuilding will take that, it can repair that. So any questions at this point? If not, I'll keep going. And so the next thing I'm going to do, so I've got these results in a table, in this DBCC results table. I'm going to run this script, which is going to truncate a page results table. It's going to create a couple of temp tables, and then it is going to select out of the that DBCC results table, join to sysobjects where my repair level is repair allow data loss, and my object name is corrupt data, because that's the table that I've corrupted. And I'm going to select that into this DBCC pages temp table. I'm then going to loop through that table, grab the first row out of it, and run DBCC page. And I'm going to insert that value into page results. So this will run with table results. So we saw the table results previously. It's going to end up inserting these into my page results table. And I will select out of that to show you what it looks like. And then finally, and actually let me just run this, and then I can step through that last process. So when I select from page results, it gives me the result set that I looked at previously. And if I scroll down in here, you'll see after my header information, I've actually got my column names here and my column values. And that's great, but I want to be able to read these, to pivot these values out. So if you're familiar with the pivot command in SQL Server, that requires an aggregate function, and it is generally works, it always works with numeric data, because you need to use it with a sum or an average or some kind of aggregate function. This construct here actually does that pivot for text data, and I found this online, and I have not been able to find the example that I used again, because I really want to give the person who did this credit, because this really saved my bacon in this case. But basically what this is doing is it is selecting out of the page results table, and it's using this case statement to look for this value, look for the column value, and then it pulls that value out along with the, or actually you're casting or creating the column header, and it's pulling this value out. And these are the results you're seeing down here. So it's giving me my parent object, and then my ID number, phone number, first name and last name. And here you can see Mayam, the value that I changed. And you can also see that there are 147 rows that are affected. So this is the page. This is page 328. And these are the row values of the 147 rows on this page. So in this case, I can go back to the client and say, this is the data that was affected by the corruption. If there were multiple pages that were affected, you would see more than the 147 rows. And this is what they were looking for. This is what the client was looking for. So what I would say about using this is this demo. If you run through this demo, and I should have said at the start that all of the database and all the objects I'm working with, I will provide the scripts for creating those, so you can run through this from start to finish. But this is good to give the client, to give them a sense of how kind of prevalent the corruption is. There could be a case where the best way to get back from corruption is to have a good backup to restore from. But if your restore is going to take 6 hours and there are 147 rows that are affected here, it may be quicker and faster to have someone re-enter this data, to delete the data out and have it re-entered. If that's going to take 15 minutes for someone to do, that could be a better option than running that 6-hour restore. So it's something where you have to kind of balance the time versus the effort versus accuracy. So that is kind of the demo of this process. I've got a couple of more slides where I talk about some other stuff, but anybody have any other questions? And I see that there's, Mike, you said that you've never had a corrupt page in 15 years. The saying goes that there are two kinds of DBAs in the world: those who haven't experienced those who have experienced corruption, and those who haven't experienced corruption yet.
Yeah.
Something else.
As soon as I wrote that, I was hoping I wasn't kind of shooting myself. So I was chatting with Mike Walsh, who had like 4 or 5 last week alone over the weekend. I'm like,
yeah,
man, I just thank God I don't have it. But
yeah, well, something else I'll say: if you take these scripts and run through them, you can run through this process, and I would advise doing it, because if you are comfortable with running this stuff and you have an idea of how to do it, it's a lot easier to do it when you have to. When you have an officer breathing down your neck trying to figure out how extensive the corruption is, if you are familiar with running these commands and interpreting the results, it's a lot easier to be familiar with it than not. So
yeah, I've gone through this stuff, about once a year. I do a session like you're doing here, or I listen to a session just for that purpose.
Right.
So I'm not totally out. I haven't had to do it with a live patient yet.
Well, I hope that you don't, because
Check with
interesting.
me fast. We'll see what happens.
All right. So as I said, I believe I've got a couple of other options or slides here just to talk about other DB options. There are 2 options to repair data, and they mirror the repair levels that we saw in the result set: repair rebuild and repair allow data loss. In both cases, to run them, the database has to be in single user mode, and repair rebuild, it'll repair issues with non-clustered indexes. It will use the information from the clustered index to rebuild the non-clustered index. And if you have both repair rebuild and repair allow data loss, repair rebuild won't work. If you try to run it, it will come back and it will tell you, I can't run repair rebuild because you have to fix the repair allow data loss first. Repair allow data loss, it will do whatever is necessary to repair corruption. This includes deleting data. You can note allow data loss in the command name. It doesn't know anything about constraints. So if you have constraints on your data, if there are constraints between the table that is corrupt and other tables, SQL Server doesn't care about those. It doesn't know about those, so it will delete the data and your constraints will break. This is a last resort. You don't want to do this unless you've exhausted all other options, and you want to back the database up before you do this, so that if you run it and you figure out that you don't want the results that it's given you, you can restore from that backup. There is a parm that you need to run on a restore statement if you're restoring a corrupt backup, and I can't remember what it is off the top of my head, but just something to note. If you try to restore a backup that is corrupt, SQL Server will tell you it is corrupt and will not continue. But there's a with parm you can put after the with command on the restore that will allow it to continue. It might be with continue after error. Just one last warning, running this command without following the previous suggestions may be a resume updating event. So you want to be very careful running repair allow data loss. This is, as I said, the best way to get back from corruption is to restore from a good backup. This is a reason that you really want to know that your backups are running successfully, and you want to be able to restore. You want to test your restores periodically. so that you know that your backups are good. Because, if you run into a situation where you have corruption and you find out at that point that your backups haven't run for a week, that's not when you want to find that out. You want to make sure that you're alerting off of your backup jobs to make sure that they're running, and you do want to test your restores. And actually, I just remembered that I wanted to show you how to set up the alerts for the 823, 4, and 5. So if I go back into SQL Server Agent, I've got my jobs, my job activity monitor, but here I've got alerts. And I don't have any set on this machine, but if I right-click here and say New Alert, I can name this. I can call this 825, and I've got this type, and I've got a SQL Server Event Alert, and I've got a radio button here. Actually, let's see. That's not what I want. So I've got my radio buttons for error number and severity. So severity, I can alert on a specific severity level, but error number allows me to actually input an error number here. So I can put it in 825. I have options for response. I can execute a job, or I can notify an operator. So you can configure an operator in SQL Server Agent, and it will have some communication associated with it, an email, a pager, or NetSend. If there's anybody out there that remembers NetSend, it would actually pop up a dialog box in your Windows session. But this is how you set up that alert. And then you have some options. You can include the error text. You can set some additional information. And then you can set up a delay here. So what this does is it prevents you from getting flooded with alerts. If you have something that's happening every second, you can set this to, say, 5 minutes, and it will alert once. You have an opportunity to get in, log in, see what's going on, and then it will give you another alert 5 minutes later. It'll prevent your email from getting flooded or your pager. So that is how to set up an alert. Are there any other questions?
Yeah, there are a couple here. Okay. One is, I think you answered it, but I want to ask it specifically because it kind of fit right in there. Do you recommend to restore the backup immediately after finding corruption, or what do you find the best practice?
It depends. I mean, if you want to do this analysis, it depends on, when you test your restores, one of the things that you should keep track of is how long those restores take. So it depends how quickly you need to get the system back up and running. If your restore is going to take 6 hours, you might want to, start the restore and do some analysis. It just depends on how quickly you need to be back. Like I said, if it's going to take you 10 minutes to get the database restored, then go for it. One thing to keep in mind is if you're not running CHECKDB, on a daily basis, if you run it weekly, if you catch it, if you're running it every Sunday and it flags corruption on Sunday, there's a possibility that corruption could have happened on Monday. So if you're running full backups, differential backups, log backups, you could restore to a point in time and still see the corruption. There are some resources on Paul Randall's blog about determining when corruption occurred. So there are ways that you can try to pinpoint when corruption occurred and do a point in time restore to that, but it really does depend. And if you have other questions about it, feel free to shoot me an email or hit me up on Twitter, and I'd be happy to talk about it.
Okay. Here's a question that I'm just going to ask it. So how frequently should you run DBCC? Some are saying run it every 2 weeks in production databases, which are data warehouses, of course, certain multiple terabytes. Some of the SQL servers are virtual. I'm not sure how that makes a difference, but in their SAN storage, is every 2 weeks okay? It's kind of the question, right?
By default, when we onboard a client, we set up a process that runs it nightly. and then we will talk. I mean, that's if we run our process to set up our maintenance, it will run nightly. We talk to the client about it beforehand, and some have concerns about the performance impact it has, because creating that snapshot file will reduce the overhead, but it doesn't. If you have a very active system, you're going to be writing into that snapshot file, and there's additional overhead there. So we have clients who've requested that it run weekly. I would say weekly is as infrequently as I would be comfortable with. If it's a database that doesn't change very often, you could get away with a less frequent run, but I would say weekly. And there are other factors that play in there. The size of the database. Argenis Fernandez has some really good posts about running CheckDB on very large databases. I think the example that he ran into was 7 terabytes. And if he ran it straight, it was taking more than 7 days. And he's got posts about how he kind of got around that. So there are considerations. It's something that you want to test out. You want to keep an eye on how these jobs are running. If they are running for multiple, like 12 hours or more, or days, then you definitely want to look at other options. But to answer the question, I would say weekly at the minimum.
Here's a question for you. Is there any way that we can find out what caused the corruption?
Yes and no. It depends. Once again, it depends. The case, for example, the case that I ran into, the reason that I wrote this, so we encountered corruption on that initial run of CheckDB. I was running some tests, and I was rerunning CheckDB on the database, and it was coming back with corruption, but the corruption was different each time. It said your data is corrupt, but the data it was flagging as being corrupt was not the same. And it turned out that when we moved to this new production environment, the SAN array that they were using, they had IPv4 and IPv6 turned on. They weren't being used, but something in that setting was causing the actual cache in the SAN array. So you got your spinning disks in your SAN array, and there's an SSD cache above that. It was causing SQL Server to see the data in that cache as being corrupt. So by flipping those flags off, it fixed the issue. In terms of like what I just did, there really isn't a way to identify what happened there, because I'm modifying the file outside of SQL Server's knowledge. SQL Server doesn't know that I've taken the database. It knows I've taken the database offline, but it doesn't know anything about the editing I've done. I saw a question go by, or a comment go by, about how hard it is to corrupt a database. There is another command that you can use to modify a page called DBCC write page. It's something that Paul Randall wrote for troubleshooting, to actually be able to corrupt pages and test CheckDB and other processes. If you run that command on a database, there's a flag that gets flipped. And if you call Microsoft for support and they see that that flag has been flipped, they will tell you that you're on your own. By doing that, you are out of support. So just a warning there. And like I said, you don't want to do this on any data you care about. You could be a resume generating event, resume updating event, sorry.
Yeah, when we make mistakes like that, there's a 2-step recovery process. And I say this a lot at our companies. For me, it's update resume, leave town. That's what.
Yes, exactly.
And whenever they see you start sweating, they go, "Oh, Mike's getting ready to do this 2-stage recovery process."
Yep.
So when you get into large data, here's a question here, and I don't know if we have enough information to truly answer it, but and it's a frequency question. I think we've talked about it a bit, but this has a thing on it we might want to pursue. Is how about a large database that's changing a lot, and the CheckDB fails, DBCC check fails. Now I don't know what it fails with, but
it depends on what it fails with. You'd have to, I mean, DBCC CheckDB, if it flags corruption, will effectively, it won't fail. It'll process through everything. I'd have to see what it's actually failing with, and then go from there. Um, so, I don't have enough information
Yeah,
to
I
answer the
think
question.
yeah, CheckDB should run to completion. If it's failing, then there's probably something else going
Yep.
on. Okay. Um, oh, the error is coming back to snapshot too large.
So that may be an issue with
Space.
disk space.
Yeah.
So it's actually going to create the snapshot on the same drive that your data file lives on.
Right.
So, and like I said, at the beginning, the snapshot's empty. But if it's an extremely active database, then you're going to be writing into that snapshot, and that snapshot can actually get too big. That's why you want to, in that case, running a backup and running CheckDB on the restore of a backup may be your best option. But I'd have to, do to look at the situation. But that is a workaround there, and somebody asked what Argenis' last name was, and I saw you posted a link. It's Argenis Fernandez, and he has some really good information out there about large databases that will give you some insight. So I can, if there are no other questions, I can just run through these resources really quickly. So Paul Randall, he has a blog at SQLskills.com. This is a link to CheckDB from every angle. So I think there's something like 100 blog posts out there. If you start at the bottom and work your way up, you'll find the link to CheckDB kind of step by step. Paul Randall on DBCC page, so information about how to run that. Something else that I didn't point out is that dynamic management function I'm using that was introduced in SQL Server 2012. If you're running this on 2008 or earlier, there's another command called DBCC IND that you will have to use, and there's information about that here at Paul's link. This link is Jason Straight talking about the dynamic management function, how it differs from DBCC IND, the different parameters you can pass to it. That's the link about checksum versus torn page. Paul Randall on 825s, just kind of how it is the canary in the coal mine. And then MSDN links to 823 and 824. And then finally a link to the hex editor that I used. So like I said, it's a freeware program. They ask for donations if you like the tool, but it is completely free for you to download and use.
All right.
Any other questions?
No, Frank, I think we've kind of covered all the key ones here. But with that, I want to say thank you very much, Frank. It was a good lesson, and myself and others are going to play with this stuff preemptively. So if we do ever find ourselves in a situation, we are somewhat have some fair degree of muscle memory in how to do this kind of stuff, which I think is really a good idea. So with that, I say thank you because you've put it back on my radar again. That's been really good. With that, I want to kind of chat about a couple of VC administration things. As you know, we do raffles for these sessions. And this week we have a special treat in that we are raffling off 2 free PASS Summit registrations. So PASS headquarters has chosen 2 folks, and they'll be choosing 2 folks today who will receive free admission to the SQL PASS Summit that's coming up at the end of October. This includes the conference registration. It does not include airfare or accommodations. So with that, we'd like to say thanks again for Frank for taking the time out. It was very good. I appreciate it. A lot of good questions, a lot of good interest in this. And with that, we'll see you the second week in October. Thank you, everybody.
All right. Thanks a lot.